We are live.
Yes, sir, we are live.
So hello guys, good evening. Welcome back to Margdarshan by IITians. तो guys, आज हम लोग पर्सनल इंटरव्यू सेशन स्टार्ट कर रहे हैं. We are starting a personal interview session for IOCL. Recently we have started GDGT. So now we are starting personal interview session. So today with us, Mr. Shodhan Shetty from Manipal Institute of Technology is there. He is also preparing for MRPL and IOCL, and also campus placement. So today we will be taking personal interviews of Shodhan, and let's start Shodhan. But before starting, I will be introducing our batches. Guys, आप लोग हमारे परमाणु बैच एंड अभियान बैच दोनों एनरोल कर सकते हैं. परमाणु बैच स्पेसिफिकली डिजाइन फॉर BARC, Department of Atomic Energy, NPCIL, ISRO. Abhiyan batch is specifically designed for GAIL, IOCL, ONGC, MRPL, etc. ओके. अरे आवाज कम कर भाई, सेशन चल रहा है. तो यस शोधन, प्लीज इंट्रोड्यूस योरसेल्फ.
Hello, sir. Myself, it's Shodhan T. Shetty. I'm from Manipal. I'm studying in Manipal Institute of Technology. I'm currently finished my third year of BTech Chemical Engineering, and I'm going into the final year of my engineering right now. And as far as my chemical engineering thing is concerned, I've been doing a couple of internships in the chemical engineering field of late. I have tried myself best to be involved in this stream of engineering, and I've also made sure that I get enough experiences through various internship as well as training. Also, I've made myself focused and got some necessary experience in terms of management, as I'm in a management committee member of ISCH Manipal student chapter. So as per my hobbies are concerned, apart from the obvious hobbies that I have, I also try to make myself equipped with the latest advances and trends in chemical engineering right now in the world. Thank you, sir.
Okay, so Shodhan, please tell me what in which industry you have done your internship.
First, I done my training in a petrochemical industry, and it was MRPL. And then I have done my internship at the Indian Institute of Petroleum, which has got a CSIR status. And I've done my project in biofuels division, which is actually the process for sustainable aviation fuel.
Okay, so you have done basically from petrochemical. So please tell me what is the difference between petrochemical and petroleum.
Petrochemical, usually it deals with all the byproducts and the products that deals with the petroleum feedstock related ones, whereas petroleum refinery deals with the refining of crude oil, etc. So we derive petroleum related products, whereas petrochemical, it is getting a byproduct which are from the petroleums.
Okay, so if I say, like, there must be unit processes, right, and
Yes.
unit conversions. So can you please tell the difference between this unit processor and conversions?
There are unit process and there are unit operations. If I have to speak of unit operations, it consists of things like filtration, sedimentation, etc. Whereas unit process, it deals with the reactions that bring about a necessary change in the overall system. And the processes involves various reactions involving in a reactor, and the process also involves distillation, etc.
Okay, that's great that you have caught me, right? You have basically said, uh, yes. So Mr. Subodh sir is also there with us, right? Okay, so he will be also there presenting with us. Okay. So Shodhan, please tell me, in MRPL, as you said that you have done your internship in MRPL, so MR in basically pe- petrochemicals, right? So right, in petrochemicals. So please tell me, like, what was the procedure there? You must have seen their hydrogenation, you must have seen their alkylation, you must have seen their hydration, right? So please tell me,
Yes.
like, which chemicals, on which petrochemicals you are operating, and what you have learned there.
Basically in MRPL my training was for 30 days, and it was required of me to go into various process plants which are there in the MRPL. For example, there was CDU, that was crude distillation unit, followed by a vacuum distillation unit, and then there were several cracking units like FCC units, etc. So it was basically me being in the training for a day or two on each unit which are there in MRPL. So it was basically CDU, VDU, then hydrogen units, then Marox units, then fluid FCC units, and the last one, the residue units.
Please tell me in detail about the CDU, VDU, ADU.
So in crude distillation unit, after all the necessary pre-treatment were done, the feed which was sent into a crude distillation unit, and the distillation was done at the atmospheric pressure, the crude distillation unit, and from them there were later cut products as well as the higher cut residues, and this higher cut residue was sent into VDU, the vacuum distillation unit, where the distillation was the carried distillation was vacuum distillation, and from the vacuum distillation, even the furthermore on basis of the temperature cut, furthermore process or the residues were taken out. And in
Okay,
the CDU unit, basically there were many pre-treatment as well, like a desalter units, etc.
yes. You have done internship in IIP, right? Indian Institute of Petroleum.
Yes,
Yes.
yes.
So, what you have done there? Please tell me. Like in which unit you
Basically,
were?
in IAP, there are a lot of research going on, but there is a specific project called as SAF, Sustainable Aviation Fuel. So we are placed in that Sustainable Aviation Fuel project, and we're meant to see the process how it was done, and to know about the various chemistry involved in the process as well. So in terms of plant, it was a plant which used the petroleum refinery techniques to use feedstocks such as jadropa oil or waste cooking oil to convert into biojet fuel, which was basically a kerosene cuts along with diesel as well as naphtha. So in my training and the internship experience there, I got to know how the process was carried out, what was the pre-treatment techniques used and the post-treatment techniques used. I also got to know about the distillation used there to get the naphtha, biojet fuel, as well as the diesel cuts from that.
Great, Shodhan. Shodhan, I would like to ask you, like you have said that you have been in the sustainable department, right? In the IIP. So you must be aware of green hydrogen, right? Please tell me what is green hydrogen.
In the IIP, for the feedstock, they required hydrogen along with the waste cooking oil or jet propane to carry the hydro processing thing. So they used water splitting technology or the green hydrogen for that purpose. Basically, they have used a big machine that uses water splitting method to produce hydrogen, which we term it as green hydrogen. So it is not done by any other method that is currently used in the industry to produce hydrogen.
It is not something like that we are producing hydrogen with the help of resources which are renewable resources, right? That is green hydrogen.
Yes,
Okay.
yes.
So
So we are using water to get hydrogen.
we are using water.
Water. We are splitting the water, so we'll get hydrogen as well as oxygen. That
Okay.
hydrogen is utilized there.
So please tell me, like you have been into the MRPL, like you were in the petrochemical department, right? So please tell me,
Yes.
what are the productions? What are the methods to produce hydrogen?
Uh, the methods to produce hydrogen. Basically, I've not been into hydrogen unit much, so I know less about that. But if I have to pinpoint, I'm not sure about that.
Okay, no issues. I will be telling steam naphtha is there, steam methanation is there, right? So
Yes, sir. And
basically,
steam reforming is done. Okay,
steam
yes.
reforming is
Steam
also
reform.
there. है ना? Naphtha reformation is okay. So yes, please, Subhash sir, you can ask some question.
So, because we are at hydrogen, what are the uses of hydrogen, let's say, if any, if you know, in energy perspective?
Basically what have been in the industry so far, they are used for the hydro processing things mostly, if I have to be
Correct.
industry relevant in terms of hydrogen. So it's
Mm-hmm.
mostly used for hydro processing, where the hydrogen is used because through hydro processing uh, we can actually get many hydrocarbon products via hydrogen. So and we are using that hydrogen with the suitable catalyst also, so we can get the required cyclization or the aromatization reactions that happen.
Correct. So I'm talking about hydrogen as a fuel. So why hydrogen is looked after as a like potential very good source of energy in future.
I mean, it's termed as a clean fuel, the hydrogen
Correct.
fuel,
Correct.
and it has the hydrogen has it's looked after as one of the future fuels, because the present resources, the fuels that we have problems with their emissions, which are mostly the hydrocarbons that we're using so far. We will not be having the same problem with the hydrogen, given that we
Right.
produce the hydrogen in the right methods, not with the methods that are currently prevent that are providing more emissions which are not in regulations. So if we can produce hydrogen in the right method, I think it can be a clean fuel, and it can be a fuel for the future as well, without worrying about the current resources in terms of fossil fuels, etc.
Correct. So that was on the pollution side. There is one more actually. Calorific value.
I know of the calorific value, yes, sir, but I
Correct.
don't know
So
of
the
its
hydrogen
specifics.
has a extremely high calorific value because there is literally no byproduct.
Yes.
Everything that we have that will generate some heat, generate some energy. So I'm not very sure, but it has a very high calorific value per kg basis. But
Yes.
the problem with hydrogen is that because it's in gaseous form and it's very hard to condense into a liquid or pressurize into liquid. So volume is the issue that industry is currently facing. So although it has a very high calorific value per mass, but its calorific value per, let's say, volume is still very low.
Okay, sir.
Cool. Uh, so let's say you have a container and you want to create, you have a container, let's say cylindrical container also, and you want to make it into or convert it into a thermos kind of. Okay. So for example, you are storing some liquid nitrogen, liquid oxygen, something like that. And liquid oxygen, liquid nitrogen, those operate or those exist at very low temperatures, right?
Yes.
And I don't exactly, I think minus 120, minus 130, 160 degrees Celsius up to that. So in that case, your container need to be thermally very well insulated. Now you have been given the freedom, you have been given the liberty to, create a thermos. So like one of the main, or we can say the only important thing in a thermos is the walls. Like how would you design the wall? So let's say you have been given the liberty. How would you design an excellent thermos? For example, what would be the criteria and how would you go ahead?
First, I will think in terms of material that has to be used to prevent
Correct.
the heat loss from inside to outside, or even the heat entering from outside to inside. So I have to select a suitable material. Secondly, I
Mhm.
have to, in terms of calculation, I have to calculate a right critical radius of insulation for that the material that is given. So I will have an idea about how much thickness of the material has to be used for that purpose as well. If I have to call a term, it is called lagging. I'm not sure because I've used the same in the industry where they used to put a lagging on an instrument or so to prevent the heat loss. So these two things I'll keep in mind, the material as well as the critical radius of insulation.
Correct. So can you comment about material or insulation? Like, can you think of some insulation, something like that? If you know.
If I have to think of an insulation, if there is a material, I just have to wrap it. It has to be a glass wool, or it can be an asbestos, or it can be a
Correct.
silk as well. But how much, depending upon how big a container is or how much relevant it is, I'll go for the material. It has also to do with the cost of the material, as well as the how the material gonna sustain. Like, is it too delicate or it can sustain or not?
Correct. So the material that you talked about, the glass wool, the silica gel, and all those things, they have one thing in common, that is they are very porous in nature, right?
Yes.
So why is that? Like why we are going after some porous kind of thing here? Can you give me some idea?
Uh,
Most of the
they are
refractories, like even the refractories that are used in blast furnaces also, those are also some brick type of structure, and those are also very porous.
It has to do with it has to do with the nature of insulators, I guess. I'm not sure. Given the insulators, they have very low intermolecular force of attraction, and even they are not tightly packed, as we say. So it might have to do with that, but I'm not sure.
Okay, so let's say we have a thermos. So there is some internal container, then there is an external container, right? The internal container houses the liquid that we want to keep. An external container is the one that is being, coming in contact with the surrounding. Now we'll have a gap in between these two containers, right?
Yes, yes.
Yes. So how would you fill this gap?
Uh,
Because now you want it to be very well insulated. So can we keep air there?
uh, I think it can be. Air can be. They are the poor conductors of heat, air.
Perfect.
So
Can you
air
think
can be filled.
something better than air?
It has to be something that doesn't conduct heat that much. We have to make sure conduction is less. So
What if there is a vacuum?
yeah, vacuum is good.
Yeah, exactly. Now the only thing with vacuum is that then we will have a 1 atmospheric pressure on the outside, and there is no pressure on the inside, right?
Yes,
So
yes,
the overall structural rigidity of the whole container get collapsed. So that is the reason we keep air there.
yes.
Okay. Now the problem with air is that because we are having very thin walls. So thin is very subjective word actually, but you can understand the temperature difference is over, let's say, 100 degrees Celsius, 150 degrees Celsius between inner container and external container, and thickness is not very high, not in meters, it's in maybe like mm's or something
Yes.
like that. So even in that, because the thermal gradient is so high, the air happens to form a circular path, and it will start conducting the heat. Although air is poor conductor, it will start conducting the heat. Now, can you comment on why we are having porous media there? Like, what is the
Uh,
purpose of putting porous things there?
since you said they form like a circular motion, the air,
Right?
we want it to pass through that, so it uh, doesn't circle around the same path. We want
Correct.
it
So
to
actually,
pass.
actually, we don't want it to pass, and that's why we are having porous things there. Essentially, although I agree with you, porous will let the air circulate, but not as much as it would have been had there been no porous media at all.
Okay.
Are you getting
So
it?
it
Let's say
basically
there is
keeps it. So basically, it keeps air completely distributed among the material.
exactly, and it doesn't let it pass as nicely or as seamlessly as it would have been without anything at all over there. So that is the major reason of porous. Also, not just that, porous media itself are very poor conductor of heat because there is hardly any surface there. Everything is filled with air only. And also they provide some structural rigidity, which is very important at that point of time. Perfect.
Okay.
Now let's say you want to create liquid nitrogen. You want to manufacture liquid nitrogen. How would you do that? Like we
Mm,
have nitrogen, right? I want to get the liquid nitrogen from the atmospheric air, not through some reaction or something like that. So essentially, we have liquid nitrogen at I don't know exactly what is the temperature, but maybe around minus 120,
minus
minus one.
195, sir.
Okay, so that's even lower than what I thought. So minus almost minus 190 degrees Celsius. So how would you approach this problem? Because see, you can always cool up to one minus 190 degrees Celsius, but that might not be the efficient way. So how, if you
So,
can think?
so we have two parameters. It's a temperature and pressure. As you said, temperature, I think it's not feasible. So we'll go
Right.
with pressure. So we'll be
Mhm.
compressing the gas, and there has to be at a certain level where liquid actually the gas transforms into a liquid, and we compress the gas into the liquid. So compression can be the method to get it around minus
You
195.
are right, but you are half right. See, to get it into liquid form at the room temperature, that pressure will be enormously high.
So we use vacuum.
No, how
So
would
we
you use vacuum?
when we use vacuum, we can bring the atmospheric equivalent temperature down. So we can actually compress the nitrogen at a very low temperature than the expected ones.
Can you repeat? I didn't get you. Like how to use vacuum?
It's just that I'm using the idea of the vacuum distillation thing here as well.
Okay,
So as we using vacuum, we are actually bringing down the temperature of the AET cuts. So basically, if you can do the same thing in the nitrogen, we can actually compress the nitrogen at a pressure, at a very low pressure using vacuum. So it can be done at room temperature as well.
but we are compressing it. We don't, like compressing means we are increasing its pressure.
Yes.
So, okay, fine. What is the relation between saturation pressure and saturation temperature? You know the TS diagram, right?
Yeah, I know what you are saying.
So, if we increase the pressure, what happens to the saturation temperature?
It increases.
Correct. So now, uh, can we use this particular thing to get liquid nitrogen? You are right. You are right that we will compress it. But the point is to compress it at the room temperature. The pressure that we will need will be enormously high. Maybe we
So we
won't have
have
that.
Yes. So then we have to decrease the temperature, the saturation
Correct.
temperature. So
Correct.
we can,
And
so it doesn't require enormous pressure to actually compress the
right.
gas.
So here we will be decreasing the saturation temperature or increasing the saturation temperature in this case.
We have to, we have to get it to subcooled state. So we are actually moving from saturation to subcooled state. So we're actually decreasing the temperature.
I see. So how it is usually done in industry is we first compress it, and on increasing the pressure, its corresponding saturation temperature will rise.
Okay.
Are you getting it? So now
Yes.
before it was we were getting liquid nitrogen at minus 190 degrees Celsius. Now we will get it maybe at minus 100 degrees Celsius or minus 90 degrees Celsius, something like that. And
Okay.
now at this stage, at a compressed stage, we will cool it down.
Okay.
So it's the combination of both compression as well as cooling, which gives us the liquid nitrogen. It's not only compression, it's not only uh, cooling down either. So it's a combination of both. We get that one sweet point in between, wherein there is not, where is the combined energy input for compression as well as the cooling down will be at manageable scale. Because as we compress it further, the gas compressors tend to get less and less efficient. Because
Got
now
it.
one can't use the centrifugal compressor, one has to use the reciprocate one because they offer
Yes.
higher pressure ratios and something like that. But again, then the problem comes that we need to have that much perfect machines where there is no leakage, there is less to no leakage, something like that. So like, yeah.
Okay. So, Shodan, I would like to ask you a few questions. Like, do you know the working of air cooler and AC?
Yes, sir. I think it has to do with it. The principle is same as that of an air compressor.
No. I would like that. What is the principle? Basically, that only I am asking, right? I am not asking that it is the air compressor. Right? Please tell me what is the principle behind air cooler and what is the principle behind refrigerator, AC, air conditioner.
Uh, Not exactly sure about the principle.
Okay, no problem. Do you know about humidification and dehumidification?
Humidification, I know, sir.
Okay, please tell what is humidification
It's converting the vapor phase into the liquid phase.
and what. And so dehumidification will be what? It will be the reverse of humidification, right?
Yeah, liquid to the
Okay.
vapor phase.
Yes. So the room cooler or air cooler basically works on the principle of humidification, and air conditioner works on the principle of dehumidification. Okay.
Okay.
Please tell me, like, you must be aware of, like, we were having earlier window ACs were there, and as of now we are having two split ACs. So earlier, as we were having window AC, as we were having window AC, why, what was the need to bring two split AC, or why two split AC is beneficial over window AC? Are you aware, or may I change the topic?
No, I'm not too sure about the Windows CC, sir.
No problem. So we will be ending our session here only. We will be concluding. Okay. You are basically very good, so that you will be cracking any of the interviews. Okay. Somewhat points are there, like you have to be focused on something, like this मास ट्रांसफर वाला थोड़ा सा पार्ट जो है, इसमें आपको थोड़ा सा होना पड़ेगा, है ना। साइक्रोमेट्री वाला पार्ट मैं आपको बता दूंगा कहाँ से पढ़ना है, कैसे पढ़ना है करके। ठीक है। नेक्स्ट है, अब जब आपका नेक्स्ट सेशन होगा तो उसमें हम लोग हीट ट्रांसफर फ्लूइड मैकेनिक्स से क्वेश्चन देखेंगे, है ना। और बाकी वैसे तो आपका बढ़िया ही है। थोड़ा सा ये वाले पार्ट पे फोकस करना है, जो ग्रीन हाइड्रोजन वाला पार्ट है ना। और जो स्टार्टिंग में जो मैंने क्वेश्चंस पूछे थे उससे रिलेटेड थोड़ा सा डीप में चले जाना। ओके। आप
Okay.
एनपीटीएल के वीडियोस देख सकते हैं। एनपीटीएल के वीडियोस में अच्छे से डिटेल में है ना। और कुछ केमिकल प्रोसेस सीपीटी करके होता है अपना, केमिकल प्रोसेस टेक्नोलॉजी, है ना, केमिकल टेक्नोलॉजी जो होता है वो वाला थोड़ा सा पार्ट आप पढ़ लीजिएगा, राइट। पेट्रोलियम रिफाइनिंग से और पेट्रोकेमिकल रिफाइनिंग से। ठीक है। एनपीटीएल पे अवेलेबल है।
Yes.
ओके। उसके नोट्स भी अवेलेबल है। ओके। तो वी विल बी एंडिंग आवर सेशन हियर ओनली गाइस। मैं आप लोग को फिर से बता देता हूँ, हम लोगों ने इंटरव्यू प्रिपरेशन की दो बैचेस लॉन्च करी थी। एक थी आपकी अभियान बैच और दूसरी थी परमाणु बैच। अभियान बैच में आप लोग एनरोल कर सकते हैं, जो कि स्पेसिफिकली डिजाइन है फॉर गेल, आईओसीएल, ओएनजीसी, सीपीसीएल, सीजीपीडीटीएम, जितने भी आपके पीएसयूज है, जहां पे भी आपका जीडी, जीटी और पीआई का प्रिपरेशन, जीडी जीटी जिसमें मांगा जाता है, उसमें आप लोग अभियान बैच में आप लोग एनरोल कर सकते हैं। और अगर आप लोग को टेक्निकल इंटरव्यूज में जाना है तो आप लोग बार्क एनपीसीआईएल डिपार्टमेंट ऑफ एटॉमिक एनर्जी जो परमाणु बैच है उसमें एनरोल कर सकते हैं। तो चलिए गाइस, हम लोग आप लोगों से विदा लेते हैं। अलविदा। गुड नाइट गाइस। लाइक करें, शेयर करें, सब्सक्राइब करें हमारे चैनल को। और गाइस, बहुत काफी लोग एनरोल कर रहे हैं, आप लोग भी आइए, हम लोग का फायदा उठाइए। मार्गदर्शन इसीलिए आया है, एक इनिशिएटिव के साथ में आया है, ताकि आप लोग हमारा अच्छी तरह से यूटिलाइज करिए। एक चीपेस्ट प्राइस में हम लोगों ने इंटरव्यू प्रिपरेशन लॉन्च किया है, तो आइए इसका फायदा उठाइए। और गाइस, भूलिएगा मत, मार्गदर्शन ने गेट 2024 एस्पिरेंट्स के लिए इस संडे 16 ऑफ जुलाई को स्कॉलरशिप टेस्ट रखा है। उस स्कॉलरशिप टेस्ट में 100% स्कॉलरशिप है फॉर चुनौती गेट टेस्ट सीरीज। तो आप लोग आकर ये स्कॉलरशिप टेस्ट दीजिए, जो कि आपका सुबह 11 बजे होने वाला है। थैंक यू। हैव अ नाइस डे। चलिए सर, मैं एंड कर